Well, I wanted to talk about my newest upgrade to my chicken tractor. I did a whole video last year on the chicken tractor, and it worked perfectly fine, although it needed some improvement. And so the first improvement I did this year, I put a power lift onto it. And what I mean by power lift, it lifts on its own power. I have already power on the chicken tractor because it's solar powered for the doors and everything. So this is running about 5 times normal speed, I think, and it lifts up about 3 inches higher than the old system, and that's really what I wanted. I could have gone up to 10 inches higher, but that's a lot more weight up than swaying back and forth when I'm driving it around. And I thought, well, this is probably good enough, and I'm sure it will be. And what's nice about this is that I can just flip the switch and walk away because the limit switches will stop it on the electric jack, so both up and down. So it made it real easy to activate this. The old system I had last year, this worked fine. It's just that it didn't lift it near as high, and boy, I couldn't lose too much weight. I'd have a hard time pushing this down. Now, I could have made this lever arm a little longer here, but that would have made it a lot harder, longer for me to push down. And I was always scared of, having my foot slip off this and it popping back up and hitting me. It never did, but I thought instead of just trying to fix this, I'm going to replace this, and that's what I did. Now, what you didn't see in the back of the chicken tractor, under the hopefully out of the rain, there's this little box I made here. This is a 3D printed box. Now I'll post this to Thingiverse if anybody wants it to. It just holds a little 1/4 inch switch. It's a double pole switch. It's called. I'll talk about that later. That actually activates it, which is nice because it's got three positions. It's all the way up as one, raise it up, middle nothing, and then you can switch it down again to drop it. Um, I was able to just drill a 1 1/8 inch hole and then plug the cigarette lighter right through it. And I thought it was connected because this is a car uh, electric lift. And it was really a simple one to do the electronics on, hooking it to the battery. Now, my switch, well, behind the switch, I should say, this is my jack here. Now it's painted gray, and it says it's a 1.5 ton jack. And I see these are still on the web. They call themselves now 2 ton jacks. They look like the same thing. I'm not sure I even use this for a 1 ton, but my chicken tractor it probably was 300 some odd pounds. I added probably 100 pounds of steel to it, so I'm in the 400 some odd pound range, give or take something. I'm well within the limits of this jack to do this. And I'm thinking, well, I know this jack's not going to last forever. And in fact, I bought this for a project a couple years ago. I ended up using a linear actuator for, and I know these jacks they wear when they're getting used. But I started thinking, well, if I move this chicken tractor every week, well, that's 4 times a month, and if they're in it for 6 months, that's you know 240 times cycles up and down. That's like 10 years. So I thought this should last long enough. And worst case scenario, it's all just bolted in place. I can replace this if necessary. So that's why I chose. I had it. Now, regardless if it's a 2 ton, 1.5 ton, even the 5 ton, it looks like all these controllers have the same type of controller. Now, this controller was nice. However, it's designed to be used with you right by the car. And I needed this controller to be outside on the back of the chicken tractor, which is about 2 foot longer than this hand controller was. So I had to modify this, and it was a pretty easy modification. If you've ever, I mean, I've done a lot of toy adaptations, and this is really nothing more than paralleling a switch, it's called, adding two more wires to every switch. Now, once you take the three screws off the back and take a couple of the screws out of the whole this printed circuit board, you're going to find these little tactile switches right here. Now, these things are not current switches, of course. You just push them momentarily, and they will supply enough current to switch on the relays that literally do the heavy lifting. They're on the back side here. But what this is that I added two wires to each switch. Now, the connectors here for each switch, with the connected to the printed circuit boards, are these little solder pads right here. Now, I could have connected it there, but electronically, if I trace this down, this trace here, all the way to here, that's the same as connecting it to that part of the switch, and the same up here. The reason I connected it down here, because there was a little wire stub coming to the printed circuit board, that it made it real easy to just put a loop in my wire, solder it right onto that, and it makes a real solid and good electronic connection. I also up here with this arrow snip one of the wires going to the LED. It had a little LED for a night light, and I didn't really want that on 24/7 when this is plugged in. I didn't want to remove the LED because I didn't want an extra hole in the case for some bugs that might think they're home. So I just snip one wire, that way it won't work, it doesn't interfere with any of the functioning of it. But also I color coded the wires, the up and the down are different colors. It makes it easier when you're trying to figure it out on your switch on the other end. I did, once this whole thing's put back in the case, I did drill a couple more holes in the end of it, just hopefully big enough to put my wires through. I also then hot glued the wires to it. That's always a good thing, just in case you get pulled on or something. It's like a strain release to keep it from pulling on your soldered wired connections in too. Now this is the switch I use. Technically it's a double pole center off, and it's really, like I said, it's push it all the way up, it's going to be one connection, in the middle nothing happens, and down other connections. Now this red thing up here, this is a single pole switch with only 3 connectors. Just imagine 2 of them together lined up but under one switch control. That's what it is. I could not find a copyright non-copyright protected picture. So what I did here, these little box in the bottom, that's representation of what you're looking at in the bottom of the switch. Now you got 3 connectors on one side and 3 connectors on the other side, and there's no connection electronically between the two. So of the 2 wires on one side and 2 wires on the other side, just put 2 on, solder 2 wires to one end on one side and 2 wires on the other end of the other side. And that will give you, then flip the switch up, middle, and down, and that will work just perfectly fine. Um, this is actually what I did before I mounted this under the chicken tractor. I mounted this between spray coatings, between painting, just on my bench, so I can get the measurements of how far I should mount the back pivot to the front there, and it actually works quite fine. And again, I think this is running 3 times normal speed. This is actually when I'm still using the hand controller. And the hand controller will still work even after you modify it. It's just another way of connecting the switch then. But the thing I used here and how I designed this, I knew this back beam, this almost torsion bar here, had to be very strong. Because, of course, these jacks are great for pushing, but of course there's no lateral support. They're just, you don't want to have these moving around. So this base here, you can see it pivots, okay? So that, because it follows the arc of this pivot of the pivot arm back here. It follows this arc of a raising up. So that had to pivot. The top can be solid because that's always, connecting to it and always pushing away from it. But what I really needed was some really strong supports so it wouldn't twist, hopefully. I didn't want this thing leaning back and forth. And so I did put some pretty good metal. This is 2-inch square tubing. And it's the same thing I used across to support the wheels, 2-inch square tubing. So that's really strong to support this whole thing. The bar I use to mount the jack to the chicken tractor, that's 1-inch, 1/8 inch tubing, square. I did actually add some additional angle iron. I'll show you a close-up of that here too. That's coming along. There we go. That's the angle iron I put on here. And now I actually use other angle iron. This is 1.5-inch angle iron, which I welded caps on each end. It's open on the other side. You can put the bolts in. But I did that to just give it that pivot. And I used what you see here, not really friction nuts. This is just, again, mocked up on my bench. But when I mounted this underneath the chicken tractor, I used friction nuts, so the whole thing hopefully won't be coming apart. I also used a little bit longer bolts because up here where it rubs, I guess no bearing, it's just metal and metal here. that there's no threads there, so they should wear a lot longer. And again, I'm if I get 10, 15 years out of this, I'll be really happy. I'm not sure if it fails how catastrophic it's going to be. I don't think it's going to be that much because it's always got one side and something is going to be holding on there. So we'll see, but I think it's going to be fine. Fingers crossed. Um, where I mounted these torsion bars in the end, again, there's no washers here. This is just mocked up here. I used some pretty strong angle iron. I usually use my plasma cutter and just kind of round the corners off, weld them in place. Um, but again, I had to be fairly strong here. Now, this tubing I used in the back, I don't know what this is called. It's scheduled 60. It's much thicker than any tubing I've ever seen. This is a galvanized piece of tubing I used sort of the bearing. There is no bearing, of course. I put some grease in there just to lubricate it for the years of use. But this internal tubing here is very thick, thicker than it's like 3/16 or even almost a quarter. I'm not sure where this came from, but it's really thick tubing, which I needed. So I used my plasma cutter to cut these holes here. I made a little template. I can just sort of make a circle, and that way I can put this tubing right through both sides of this square tubing and weld it very securely. So, because again, if one wheel drops off on something in a hole, the other one's got to support it, and I don't want the jack to take the stress. So it's really going to help stabilize the whole case here, the whole chicken tractor. Now I'm using these are the wheels I'm using. These came off of a wheelchair. I got a couple wheelchairs for the motors. And these are the caster wheels on the front. Now, if you get an electric wheelchair with batteries and a client on board, you're easily talking 400 pounds. These wheels have to be very strong because they're hitting curbs and everything else. And so, yeah, they got to be uber strong. I've seen a lot of chicken tractors on that fail because the hubs will bend or something because they're too lightweight. And I really like this design of the support system because first off, the hub is supported on both sides because of the steel. The downside of using the smaller wheels, they're narrower. They're probably only 2 inches width, and that's a lot of weight for just 2 inches. And my plan is to actually add a couple more caster, non-swivel caster, fixed casters on this beam. I'm just going to bolt them on it at the appropriate height, and that will distribute the weight. That way, if I'm actually the yard's a little bit wet, it's not going to sink in near as much because I can distribute all the weight through two more sets of wheels. But I did some test driving around with this after I got it, and it was not too much of a problem. But again, the yards were also very dry at that time. I did move the wheels a little bit further ahead because it seemed like it took a lot of weight, or had to lift a lot of weight lifting it up last year. And I was just curious, so I got my scale out, and it took 50 pounds to lift this up when it's all the extended height. And now I could probably try an experiment because the wheels, the way they lift, they come down. If I would stop it, 3/4 the way down, the wheels would still be further ahead than when they're all the way up, and it might even lift easier. But 50 pounds, I can deal with that. But it's a nice adaptation. I'm really kind of pleased how well it worked. I will be removing the side pieces and things like that and repaint it. But I just needed the height without getting too much height, and I wanted this even easier flipping a switch. So anyway, I hope this helps. I've really been enjoying the project. It's a welding and cutting project, but that's why we have welders and cutters. So anyway, have a good day, and there's Chester.